Hello, good morning everyone. Our topic for today is all about isothermal process. So by definition, isothermal process is a constant temperature process. So let's start with the PB and TS diagram. So kapag PB diagram, dalawang work yung mapoproduce mo. It's either work non-flow or work steady flow. So kapag work non-flow, di ba sabi natin work non-flow is the area under the PV plane. So maglagay lang tayo dito ng imaginary line. Yung area na makikreate mo dyan is the work non-flow. Okay? So from 1 to 2. Then sa isang PV plane naman, maglagay lang tayo ng imaginary line dito. So yung area na mabibuild mo dyan is the work steady flow or the area beyond the PV plane. Okay? So yan yan. So dalawa yung work natin sa isothermal process. It's either work non-flow or work steady flow. Then when it comes to TS diagram, yung area na mabubuo mo dyan is the heat. Okay? So constant temperature yan, kaya from 0.1 to 2, ganyan yung itsura niya. Pwedeng 0.1 to 2, ito yung 1 mo, and then ito yung 2 mo, or pwedeng ganyan. Depende sa condition ng problem natin. Okay? So, kunin natin yung formula ng work non-flow. So, work non-flow sa Thermo 1, formula ng heat natin is work non-flow minus delta U. So, ilipat lang natin si delta U sa kabilang side of the equation. Therefore, work non-flow is equals to plus dapat ito, no? So, heat is equals to work non-flow plus delta U. So, ilipat natin si delta U sa kabila. Therefore, work non-flow is equals to Q minus delta U. So, ayusin ko lang. Yeah. Okay? Then, sa work steady flow, same lang din siya ng formula natin sa Thermo 1. Work steady flow is heat minus delta KE minus delta PE minus delta H. Pero minsan, nine-neglect na yung delta KE and delta PE. Kaya minsan ang lumalabas is heat minus delta H. Pero depende. Depende naman sa problem. Kung may ibigay, edi isama nyo yung delta KE and delta PE. Pag wala, i-consider natin as 0. Then, heat transferred. Kung nakita nga natin dun sa TS diagram natin, di ba? Ang nagbago lang doon ay yung ating entropy. Therefore, heat is equals to TDS integral of TDS limits from 1 to 2. Okay, so since constant yung temperature, ilalabas natin yan sa ating integral. So therefore, Q is equals to T integral of TS limits from 1 to 2. Okay, so integrate na natin si DS. So ang integral niyan ay S. Then substitute natin si 1 and 2. Therefore, heat is equals to T S2 minus S1 or Q is equal to T delta S. Okay? Okay, so sample problem na tayo. So number 1, there are 2.27 kilogram per minutes of steam undergoing an isothermal process from 27.5 bar to 27.5 bar, 316 degrees Celsius to 6.8 bar. Determine delta S, heat, work non-flow, work steady flow with delta PE is equals to 0 and delta KE is equals to 42 kilojoules per minute. So kunin muna natin yung given. Meron tayong P1 of 27.5 bar or 2.75 megapascal. Okay? Then P1 is equals to T2 is equals to 316 degrees Celsius. So meron tayong P2 of 6.8 bar or pag convert natin into megapascal, 0.68 siya. Megapascal. Then we have a mass of 2.27 kilograms per minute, delta PE of 0, and delta KE of 42 kilojoules per minute. So ang hinahanap is the delta S, heat, work non-flow, and work steady flow. So solution, so kunin muna natin yung ating TSAT 2.75 megapascal. So determine muna natin kung saturated pa siya, superheated, or subcooled. So from the steam table, TSAT at 2.75 megapascal is 229.11 degrees Celsius. So in-average natin siya kasi ang available lang ata sa steam table is 2.70 and 2.80. So in-average natin, kinuha natin temperature at 2.70 and 2.80, then dinivide natin sa 2 para makuha natin yung TSAT at 2.75 megapascal. So it is equivalent to 229.11 degrees Celsius. So ito ay compare natin doon sa ating T1 which is 316 degrees Celsius. So therefore, yung T given natin is greater than TSAT. Therefore, the condition 1 is superheated. So kapag superheated, automatic sa table 3 tayo titingin. Okay? So, table 3. At 2.75 megapascal and 316 degrees Celsius. So, meron tayong eksaktong 2.75 na pressure. 2.75 MPa and 316 degrees Celsius. Okay? So, meron tayong eksaktong 2.75 sa ating steam table pero wala tayong eksaktong 316. So, napapagitnaan siya ng 310 and 320. So, kunin natin yung ating U at 310. Equivalent yan sa 2,774.8. Enthalpy is 3,025.9 and entropy is 6.6321. So sa ating sa ating 320 degrees, ang internal energy niyan is 2793.4. Enthalpy is 3050.1 and specific entropy is 6.6733. So kunin natin yung values by using interpolation. So mode 32, lagay lang natin 310 tsaka 320. Kunin muna natin si U1, 2711.4.8 and 2793.4. Press AC, shift 155. Lagay natin si temperature which is 316. Therefore, U1 is 2785.96 kilojoules per kilogram. Okay, so kunin naman natin si ating H1. Punta lang tayo sa data, shift 1 to 3025.9 and 3050.1. Press AC, shift 1, 5. 5 din. Lagay natin si temperature which is 316. Therefore, H1 is 3040.42. Then solving for S1, same process. Punta lang tayo sa data. Edit natin si Y, 6.6321. Then 6.6733. Press AC, shift 1, 55. Lagay natin si temperature 316. Therefore, S1 is 6.6568. Okay, so okay na yung ating properties at condition 1. Punta naman tayo sa properties at condition 2. So, ang pressure natin at condition 2 is 0.68 megapascal. Hanapin natin yung Tsat niya. So, from table 2, ang Tsat ng 0.68 megapascal is 163.81 degrees Celsius. So, compare natin yung ating Tsat sa ating T given na 316. So, mas malaki ulit si given kaysa sa Tsat. Therefore, superheated ulit. So, kapag superheated, sa table 3 ulit tayo titingin. So, at table 3, ang pressure natin is 0.68 and temperature is 316 degrees Celsius. So, same pa rin nung condition 1. Ang P2 natin ay may eksakto sa table 3. May eksaktong 0.68 dyan, pero walang eksaktong 316. So, ang gagawin natin is interpolation ulit. So, 316 is in between 310 and 320. So, kunin natin yung properties at 310 degrees Celsius. Ang specific internal energy dyan is 2815.6. Ang specific enthalpy is 3080.5 and specific entropy is 7.3481. At 320 degrees Celsius, ang specific internal energy is 2831.6. Ang specific enthalpy is 3101.4 and specific entropy is 7.3836. So by using interpolation, solve natin si U2, H2, and S2. So, dito na lang So, data na lang din kasi yung temperature naman hindi na bago So, ang babaguhin lang natin is yung U. 2815.6 and 2831.6. So, solve na natin si U2. Okay natin yung temperature na 316. Therefore, U2 is 2825.1. 2825.2. Okay. Then, punta tayo sa Y. Kunin natin si enthalpy, 3080.5 and 3101.4. Press AC, shift 155. Lagyan natin si temperature. Therefore, enthalpy 2 is 3093.04. Then, last solving for the entropy. Lagyan natin 7.3481. Punta tayo sa data, 7.3481 and 7.3836. Press AC, shift 155. Kunin natin si entropy 2. Therefore, it is equals to 7.3694. So, kapag okay na yung properties natin sa 1 and 2, kunin na natin or resolve na natin yung required. So, una natin is delta S. So, delta S, simple lang naman yan. S2 minus S1. Meron tayong given na mass. Yung S2 and S1, nakuha natin sa steam table. Okay, so direct sub lang yan. Delta S is equals to 2.27 kg per minute times 7.3694 minus 6.65682. So, cancel si kilogram. Matitira dyan is kilojoules per minute Kelvin. Therefore, delta S is 1.6176 kilojoules per minute Kelvin. Solving for heat. Heat is T delta S or Ts2 minus S1. Since takwa na natin si delta S, i-substitute na lang natin para di na mahaba yung solution. So, heat natin kailangan absolute value. So, mag-add tayo ng 273 sa ating temperature 1 and 2, which is 316 degrees Celsius. Then, copy the delta S, which is 1.6176. Therefore, heat is 952.741 kilojoules per minute kasi makakancel naman si Kelvin. Solving for work non-flow. Work non-flow is equals to Q minus delta U. So, heat natin nakuha natin si delta U na lang. So, delta U is M U2 minus U1. Okay, so si heat ito 952.74 7.741 Saan na yung pen ko? 741 kilojoules per minute minus 2.27 kilogram per minute. Then U1 is 2825. I mean U2 is 2825.1 and U1 is 2785.96. So by cancellation of units, maka-cancel si kilogram. Then ang matitirang units natin dyan is kilojoules per minute. Therefore, the work non-flow is 863.893 kilojoules per minute. Then last, solving for the work steady flow, it is equals to heat minus delta KE minus delta PE minus delta H. So, heat natin, nakuha natin yan, 952.741. Delta KE given yan, 42 kilojoules per minute. Delta PE is 0, sinabi sa problem. Then delta H is mH2 minus H1. So, substitute lang natin. Heat is 952.741. Delta Ka is 42 kilojoules per minute. Then delta H is 2.27 times 3093.04 minus 3040.82. So pag kinancel din natin yan, ang unit dyan, lahat ay kilojoules per minute. So therefore, work steady flow is 791.294 kilojoules per minute. So, sakto lang parang pag mga process naman almost pare-pares lang naman ng way kung paano siya i-solve. Importante, masulat mo ng maayos yung given and makuha mo yung properties sa steam table. So, ang key lang dito para masabukatan mo siya is tama yung pag-interpolate mo sa properties and tama yung reading mo sa steam table. Okay, so last example tayo. Last example, steam at 200 degrees Celsius with an entropy of 5.6105 kilojoules per kilogram Kelvin expand isothermally to 0.515 megapascal. For 5 kilogram, what are the change in entropy, change in enthalpy, and change in internal energy? Find the heat and work non-flow, and what is the work steady flow if delta KE is equals to 0? So, given, kunin natin given. So, sinabi naman dyan isothermal, so temperature is constant. So, meron tayong given na T1 is equals to T2 is equals to 200 degrees Celsius. Meron tayong given na entropy which is 5.6105 kilojoules per kilogram Kelvin. Meron tayong given P2 which is 0.515 megapascal. Then, meron tayong given na mass 5 kilogram. And delta KE is equals to 0. So, ang hinahanap, delta S, delta H, delta U, Q, work non-flow, and work steady flow. So, solution, kunin muna natin yung properties at 1 by using T1 and S1. So, at T1 is equals to 200 degrees Celsius. So, tingin tayo sa table 1. Kunin natin si SF and SG. So, SF dyan is 2.3309 kilojoules per kilogram Kelvin. Ang SG natin dyan is 6.4323 kilojoules per kilogram Kelvin. Okay, then i-compare natin si S1 to SF and SG. Therefore, S1 is greater than SF but less than SG. Kapag ganyan, ang condition 1 natin is a wet mixture. Okay, so since wet mixture yung ating condition at 1, kukunin natin lahat ng properties sa ating table 1 at 200 degrees Celsius. So, kunin natin si Entropy, specific volume, specific internal energy, and the enthalpy or the specific enthalpy. Okay. So at 200 degrees Celsius, ang SF natin is 2.3309 and ang SG natin is 6.4323. Ang specific volume F is 0.001165 and VG natin is 0.12736. Ang UF natin is 850.65. Ang UG natin is 2595.3. HF is 852.45 and HG is 2793.2. Okay, so kunin natin si H1 dapat yan. Ayan. Ano pa yung mali natin kanina? Ayan. Okay, so kunin na natin si U1, V1, and H1. So mode 3.2, lagay natin si SF 2.3309 and SG which is 6.4323. Y is yung V muna 0.00111565, then 0.12736. Press AC, shift 155. V1 natin is 0.1020725 cubic meters per kilogram or 0.102073 cubic meters per kilowatt. Kunin natin si U1, punta tayo sa data, edit natin si Y 850.65 and 2595.3. Press AC, shift 155. Lagay natin si S. Okay, so S is 2,245. .723. So, U1 pala yan. Sorry. Then, solve natin sa H1. Punta ulit tayo sa data. 852.45. Then, 2793.2. Solve natin sa H1. Lagay natin si S1. S1 is 5.6105. Therefore, H1 is 2404.331 kilojoules per kilogram. Okay, so okay na yung ating properties at 1. Punta na tayo sa ating properties 2. Properties at 2. Okay. So, same temperature, 200 degrees Celsius, and ang pressure natin is 0.515 megapascal. So, ang gagawin natin dyan, kunin natin yung Tsat at 0.515. So, from table 2, Tsat at P2 is equals to 152.97 degrees Celsius. So, mas malaki si given kaysa kay Tsat, therefore, superheated. So, sa table 3 tayo titingin. So, at table 3, 200 degrees Celsius and 0.515 megapascal. So, wala tayong eksaktong 0.515 pero meron tayong eksaktong 200. So, interpolation lang gagawin natin. Okay, so kunin natin lahat ng properties. So, meron tayong V, Q, and S din dapat, kasama dapat dito sa S. So, ang S natin dito is, So, ang S natin dito ay, sige, maya ko na isulat. At 50 and 0.52, napapakitaan yung 0.515. Okay? So, at 0.50 muna tayo sa table 3. Ang specific volume dyan is 0.4249. Ang U natin is 2642.9 and H natin is 2855.4. Then yung S natin dyan is 7.0592. Yan. Then at 0.52, ang V natin is 0.4081. Ang specific internal energy is 2642.1. Enthalpy is 2854.3 and S natin is 7.0394. Yeah. Okay, so solve na natin by using interpolation. Mode 3 to 0.5, then 0.52. Kunin muna natin si V2, 0.4249, tsaka 0.4081. Press AC, shift 1, 5, 5. Lagyan natin si pressure, 0.515. Therefore, V2 is 0.4123 cubic meters per kilogram. Solving for U2, punta lang tayo sa data. Edit natin si Y, 2642.9. Then 2642.1. Shift 1, 5, 5. Lagyan natin si pressure 2, 0.515. Therefore, pressure is 2642.3. Then H2, ito tayo sa data, lagay natin si H at 0.5, which is 2855.4. Then H at 0.52, which is 2854.3. Press AC, shift 1, 5, 5. Lagay natin 0.515. Therefore, H2 is 2854.575. Then last, solving for S. Punta ulit tayo sa data. Edit natin sa Y, 7.0592 and 7.0394. Shift 155. Lagay natin si pressure 2, which is 0.515. Therefore, S2 is 7.04435. Okay, so nakuha na natin yung properties at 1 and 2. Masosolve na natin si problem. Okay, solving for S. So, delta S is MS2 minus S1. Meron tayong given na mass, 5 kg. S2, yan yung nakuha natin. Si S1 is given sa problem. So, substitute lang natin. Delta S is equals to 5 kilograms times 7.04435 minus 5.6105. Therefore, delta S is equals to 7.1693 kilojoules per Kelvin. So, makakancel na si kilogram. Solving for delta H is H2 minus H1. So, nakuha naman natin lahat yan. Direct sub lang. M is 5 kg, H2 is 2854.575, and H1 is 2404.331. Therefore, delta H is 2251.22 kilojoules. So, makakancel din si kilogram. So, delta U is U2 minus U1. Same lang din. Nakuha natin yung properties niya, no? M is 5 kg. U2 is 2642.3. And U1 is 2245.723. So, cancel si kilogram. Therefore, delta U is 1982.885 kilojoules. So, okay na tayo sa A. Doon tayo sa B. Solve for heat. Work done flow and work steady flow. Purahin ko na to. Okay. So, heat is T delta S. Delta S na solve na natin. Ano? So, substitute na lang natin. Yung T natin is 200 degrees Celsius. So, gawin nating absolute value. So, plus 273 para maging Kelvin na yan. Then, delta S is 7.1693. So, cancel si Kelvin. Therefore, heat is 3,391.79 or 0.079 kilojoules. Work done flow is Q minus delta U. Heat natin is 3,391.079 and delta U is 1,982.885. So unit-wise kasi parehas naman kilojoules, ano? Therefore, work done flow is equals to 1,408.194 kilojoules. Then last, solving for the work steady flow, it is equals to heat minus delta H minus delta PE minus delta KE. So since wala namang sinabi sa problem na delta PE, automatic 0 yan. Then sinabi naman sa problem na delta KE is 0, so ine-neglect din natin. So work steady flow na lang is heat minus delta H. So ang heat natin is 3,391.079 and delta H natin is 2,251.22 kilojoules. Therefore, work steady flow is 1,139.879 kilojoules. Okay, so yan na lahat ng sagot natin. So that's it for our lecture. So kung may question, paki-message na lang sa group natin. So that's it. Thank you and keep safe.